Hi, this practice is about estimating center using dot plots. The first question is, the following dot plot shows the number of books each student checked out from the library last month. Each dot represents a different student. Okay, so we see that there are many dots here, and each dot represents a student, and they give us several options that should represent a typical number of books one student checked out. Which of the following is a typical number of books one student checked out? And we see that most of the dots are concentrated on the right side of the number line, and there are distinctively many students who checked out 8 books, and there are also many students who checked out 4 books, but we see that the majority of the dots are concentrated on the right side of the number line. So if I examine these options without calculating the median, without actually calculating how many students are represented here, I can see that the bulk of the dots are here, and there is a very prominent column of 8 here. So I can assume that 7 is more likely representing the typical number of books that is checked out. 7 is more likely closer to the median of this data set than, let's say, 4. Okay, although 4 is pretty high, 8 is higher, and there are more dots on this side. So 1, of course, is not typical because there are only two students who checked out 1 book. You can see it here. And 12 books is also not typical because there are only 2 students who checked out 2 books. So I'm pretty confident that 7 is the right number. 7 is right here, and it's leaning toward where the bulk of the dots are. So I will go with 7. Okay. Next question. Isabella grows several varieties of pepper plants. The following dot plots show the number of peppers rounded to the nearest 5 per plant for different varieties. Number of peppers rounded to each dot represents a different plant. Number of peppers. Order the varieties from list to get the number of peppers per plant. Okay, so because we are estimating here and not required to actually find the median, we can see here that most of the dots are concentrated on the range of 15 to 40. Here the spread is from 30 to 70, but they are concentrated around here. So it's 45, I guess. It's typical here. It's somewhere here, 25, it's more typical. And so this is obviously the list. The list typical value on the top. Okay. List diversity, typical number of peppers per plant. Okay. And Okay, so this dot plot is more heavily centered around the 40, and here there are more dots pushing the center to the right. So I guess this dot plot has a median that is higher than this dot plot. So I think this is the order from least to greatest. This is the list, this is in the middle, and this is the greatest. Okay. The following dot plots show the number of people per table at Kingley's Bingo Hall on 3 different nights. Each dot represents one of the 20 tables. Order the nights from least to greatest typical number of people per table. Put the graph with the least typical value on top. Okay. So here, people per table on Thursday. Okay, so many tables, each dot represent one of the 20 tables. So here, on Thursday, many tables were empty, 0 people. Okay, so I think that it's obvious that on Tuesday the restaurant was the busiest, because we see that there are no empty tables here, and most of the tables, people per table on Tuesday, many tables had 7 or 8 Patreons, and diners, people. Okay, so on Tuesday it was the busiest, and when I compare Wednesday to Thursday, it looks as if on Thursday there were much emptier tables than on Wednesday. On Thursday we see that the column for 0 people per table is significantly higher than on Wednesday. So I guess the median here is lower than in Thursday than compared to Wednesday. So I will go with this order. This is the list, people per table. This is a bit higher because the column of 0 is lower and more dots are concentrated on the right side of the number line. And here is obviously the busiest day. The following dot plots shows the number of players injured per game for 3 different teams. Each dot represents a different game. Order the teams from least to greatest typical number of injuries per game. Put the graph with the least typical value on top. Okay, so number of injuries. Okay, so here the bulk of the injuries, number of injured players. Okay, so 0 players had 4 injuries, 2 players had 1 injury, 5 players had 2 injuries. So the bulk of the players who had injuries are concentrated from 0 players who had no injuries to 1 or 2 injuries. Okay, in this team, it's much more heavily concentrated on the 3. Okay, we can assume that the median is 3 because if we cancel the 2 and the 4 and the 1, it looks like the median is 3. And here it's quite an even spread. So I'd say it's somewhere in the middle, halfway between 2 and 3, because the spread of the dots is quite even across the number line. So I would say that it's somewhere here. It's less than 3. And okay. So I think that here it's obvious that the majority of the players is leaning to the left half of the number line. So this is the least typical number of injuries is concentrated on the left. Okay, which means that it's about 1 or between 1 and 2. And here it's about halfway, so about 2.5. And here it's probably 3, more closer to 4. So I guess this is the order from least to the middle to the greatest. Good. So in the next video I will do this practice, statistical questions. So I will show you in the next video. We'll see you in the next video.